Hi, good evening, everyone. Am I audible?
Yes, ma'am.
Okay. Okay. So today we'll start with week four. So there isn't a lot of theory here, but we are going to discuss whatever theory part is there in the beginning of the class, and then hopefully, if we have time, I'll cover half of your practice assignment today. Okay. Let me share my screen.
Excuse me, ma'am.
Yeah.
Good evening. First, you will take doubts or you will start with revision.
No, I'm starting week four. This new
Week
week.
week four doubts or it's revision.
No, this is the first class of week four. No? So first I'll discuss the theory part. Then we'll do practice assignment.
All right.
Okay. Uh, so the first concept that we are going to learn in week four, and the most important one, is binning. So anyone has any idea what is binning before we start? If you have gone through the lectures.
Ma'am,
Okay.
binning is used to reduce the number of comparisons of our pseudocode or a particular program.
Right. So the main goal of binning is to reduce the number of comparisons. So let's understand. So first, what we know is that some comparisons, some computations require more number of comparisons than others, right? So, for example, if I am trying to compare the marks of every two students, let's say I want to find out the first highest and the second highest marks in mathematics in the whole class, right? That means what? I'll have to maintain two variables, one to capture the first highest, one to capture the second highest. And I have to compare every two students' marks, right? Until I get those two marks that I'm looking for. So this is an intensive number of comparisons. So some computations like this, they require comparisons of, let's see. Yes, so they require comparison of each card with all the other cards in the file. For example, if you want to choose a study partner for each student. So the number of comparisons required can be very large, right? If I have 30 cards and I want a partner for every student. So all of these computations require a large number of comparison. Now we observed that if we organize the cards into bins based on some heuristic, some algorithm, then we only need to compare cards within one bin, which seems to obviously significantly reduce the number of comparisons required. For example, if I have, let's say, uh, n cards, and I'm having to compare every card with every other card. Okay, now if I divide this n cards into, let's say, 5 bins, where each bin has n by 5 number of cards. So now if I do comparison within each bin, the number of comparison decreases by a lot of factor. So even if you add up this, that is n by 5 comparisons, 5 times, since we have 5 such bins, this value will still be less than the number of comparisons that would have been performed if you didn't perform the binning. So let's understand this with a better example. So this algorithm that we want, right? That based on what will I do this binning? Based on what will I separate the cards into different files? So is there a formal way of determining the reduction in comparisons? So we have to calculate the number of comparisons first. So we need to see that it is a good factor by which we are reducing the comparison, right? It doesn't have to, if it is a very small factor, let's say if I was doing 100 comparisons before, now I'm doing 90 comparisons, that's still a very small factor. But if I was doing 100 comparisons before and now I'm doing 20 comparisons, that's a huge factor. Like I have reduced the comparison by 5 times. So we need to determine that what is that algorithm that we can use in a particular scenario that will give us the maximum reduction right? And how do I calculate this factor of reduction, the factor by which the number of comparisons are being reduced? So first, to do this, yeah,
What are you discussing today?
I'm sorry, your voice is not clear. Come again.
What are you discussing today?
This is week four theory. So we have started a new week.
Okay, from the beginning, right?
Yeah, from the beginning. This is the theory part. We'll first discuss theory, then we'll discuss half of the practice assignment.
Yeah, sure. Thank you so much.
Okay. So to determine this factor, that why how much am I able to reduce the number of comparisons in a particular situation? So there are two things we need to separately calculate. First, we'll calculate the number of comparisons without binning. That means if I have n cards and I'm doing comparison within them without separating them into different bins, then how many comparison am I needing? That is the normal number of comparisons without any binning. And now if I decide to bin them into separate files, then how many comparisons am I needing? So once I have both the comparisons, then I can find out easily what is the factor of reduction. Now, there are a few formula linked to this part of the week, but you don't have to remember those formula, right? We can always easily derive them. So take this example. I have 5 elements, A, B, C, D, E. Okay. So I want to compare each element with every other element. So if I do that, look at it like this. If I compare A with B, right? A to B comparison, is it different than B to A comparison, or are these two the same?
One and the same, ma'am.
Same, right? So comparing A with B is same as comparing B with A. So first tell me in this diagram, how many comparisons will I need for A to compare A with every other element? I will
Four.
compare A with B. Correct. 4.
Four.
Comparison 1. A with C. Comparison 2. A with D. Comparison 3. And A with E. Comparison 4. So 4 comparisons for A. Now for
Yes,
B,
ma'am.
how many comparisons will I need? First of all, from B to A, I don't need a separate comparison. From B to
Another
C, do I
three.
need? Yes.
Yes.
So B to C I need, B to D I need, and B to E also I need. So 3 comparisons. Now for C, there are already edges between C to A and C to B. So I want
And
comparison between C to D and C to E.
two
So 2
comparisons.
comparison. Now for D, how many do I need? See, D already has 3 incoming edges. That means it's already compared with A, B, and C. So just with E I need to compare. So 1 comparison. Now for E, do I need any separate comparison? It has already
No.
been compared with all 4 elements. So for E, 0 comparisons required. So in total, how many comparisons did I do? Total is
10.
10 comparisons. So this number of comparisons, 10, this is what? Comparing every element with every other element without binning. Right, this is normal comparison. So that same thing is shown here. So 10 comparisons. Now, I guess you all know this formula that for n objects, the number of comparisons required. We found out that for 5 objects, number of comparisons was what? 10. So for n objects, the formula will be what? For 5 objects, I added 4 plus 3 plus 2 plus 1. This many comparisons, right? So for n objects, I have to add n minus 1 plus n minus 2, like this up to 1. So what is the summation of this part? First, summation of first n natural numbers, if I say. The summation formula of this, that is 1 till n minus 1.
Can you scroll a little up because I am unable to see the question. Can I see the question?
This
I
is
have
the
the
question,
question.
Hmm.
right? So the question is that I have 5 elements. So if I first what I did, I compared every element with every other element without any binning. So by that I found out I need total of 10 comparisons to do that. Now I'm trying to generalize that. That for 5 elements, if I require 10 comparisons, then for n elements, how many comparisons will I need? That is 1 plus 2 plus 3 up to n minus 1. Right. So this formula, this can be written as n into n minus 1 by 2. So this is, I think, familiar for most of you. So if I now ask you that for n number of objects, what is the number of comparisons that I require without binning? To compare every element with every other element, the answer is n into n minus 1 by 2. Up to this, it is clear for everyone.
Yes, ma'am.
Yes, ma'am.
Now see, this is the same as writing this, right? So this is the same as the number of ways of choosing two objects from n objects. So at a time, I'm comparing how many? Two elements. Out of how many? Take this example. Total number of elements is 5. At a time, I'm comparing how many? 2. So I need to find out in how many ways can I choose 2 elements out of 5 elements. So 5C2. This is also 10. So the same thing, n into n minus 1 by 2. If you can't remember this derivation, you can remember it this way also. That
It is
I
nothing but
am
the
just finding out,
permutations and combinations. This is an
yeah, just
NCR
combination.
combination.
Yeah,
Yeah.
this is an NCR combination. That how many ways can I choose 2 elements out of n elements? Because at a time, you're comparing 2 elements. Right. So it is n into n minus 1 by 2. Now from first principles also we can derive this same formula. So 3 ways of deriving this formula. From first principle, so if I have n number of elements, right, what is the total number of pairs that I can form?
N into N.
N square or n cross n.
Yes, ma'am.
That's how many pairs I can form. So total number of pairs is n cross n.
25.
If I have, yes, 25. For 5, when n is 5. So for any n, total number of pairs possible is n cross n. Now from this, reduce the self comparison. So if I have this element E, I'm not comparing E with itself, right? I'm comparing E with A, B, C, D. I'm not comparing any element with itself. That means how many pairs are now have to be reduced. If I have n elements, total comparisons is n square. From that, I have to take out all the self comparisons. So n elements means how many self comparisons? N. So n square minus n. See, this part I will explain again.
Yeah. Could you
If I
please
have
come again, madam? Could you please repeat the explanation? What is going on at present?
this
The
first
one which you are
principles, right?
doing. Yes. Yes. Yes.
Look, here I have 5 elements, right? A, B, C, D, E. How many pairs can I form? Like A comma B is a pair, right? A comma C is a pair. Like that A comma A is also a pair. So how many pairs can I form with 5 elements? 5 cross 5. Every
Yes, ma'am.
element with every other
25.
element, right? So
Yeah,
25
it's
pairs I
25.
can form. Now, how many self pairs are there? Because I don't compare an element with itself, right? So I can reduce those self comparisons like AA. This pair is not required. BV, there
Like
is
five,
one such
six.
pair. So
Yeah, five.
5 such pairs will be there. So 5 square minus 5. Right. Same thing. N square minus n if I generalize it. So I can write n square minus n as n into n minus 1. Right. Just take n common.
Yeah.
Now compare A with C. Comparing A with B is the same as comparing B with A. So when we look at pairs, A comma B is a pair, but B comma A is also a pair. Right. But these two are
Yeah.
essentially the same pair.
We
That
can
means
avoid those
whatever
also.
is right. So whatever is the number of pairs, we can divide it by 2. Right. Because for every pair AB, there is a pair BA, which is the same.
Yes, ma'am.
So we can half the number of pairs. So n into n minus 1 by 2.
By 2.
So this is also another way of deriving the same formula. So 3 ways you can derive it. All 3
Yes,
ways
ma'am.
clear for everyone? Okay.
Ma'am, could you explain the second one?
Second one is just combination, right? Permutation combination that we did. So NCR formula, that is, if I want to choose R objects from N objects, how many ways can I do that? So if I have 5 elements like I have here, when I'm doing comparisons, how many elements am I comparing within? 2 elements at a time I'm comparing, right? So in how many ways can I choose 2 elements out of N elements? That's the thing. That's the combination formula. NCR, so here NC2, which if you put it in the formula, it will derive up to N into N minus 1 by 2. If you can't remember this, it's fine. Just use this one or this one, right? Now, from here,
Okay.
we can write this N into N minus 1 by 2 as half into N minus 1. Okay, same thing. So number of comparisons without binning is this. For N elements, it is half into N minus 1. Now, this number of comparisons actually it grows very fast.
Ma'am, what is binning?
Binning is that if I have N elements and I do comparisons among them without binning, then it is half into N minus 1. Now, if I want to bin them, that means if I want to separate them into different groups, if I want to form little groups inside them, let's say I want to divide N elements into 5 groups with equal number of elements in each group. So each group would have N by 5 elements. So that is, I am dividing N elements into 5 different bins. Right. Binning is a way of reducing the number of comparisons. So we'll see how binning is implemented. For now, first see why we need binning. Because as N increases, this number of comparison grows very fast. Right. When N is 2, comparison is 1. Right. Just put this N value in this formula. So when N is 3, comparison is 3. But when N is 10, comparison is 45. But when N is 100, comparison is 49,500. So that's a huge jump, right? So like this, it's almost exponentially increasing. So that's why when N becomes a very big value, then the number of comparisons becomes extremely high, right? It is very not time efficient. So how we can address that issue? See, it is a quadratic curve where it is increasing like this. As N increases, number of comparisons keeps increasing. It's a steep curve. So how do we reduce this number of comparison? Now the idea of binning comes into play. So let's say I have 9 objects, A, B, C, D, E, F, G, H, I, right? 9 objects. So tell me how many comparisons will I require if I don't use binning? What is the formula? Half into N into
N into N minus 1.
N minus 1. So just put 9 in place of N. So half into 9 into 8. That is 36.
36.
This many comparisons I would require. Now, if I want to bin these 9 elements into 3 bins of equal size. So first bin contains ABC, second bin contains DF, third bin contains GHI. Okay. Now, inside each of these bins, let us find out the number of comparisons. Same formula. Now, if I want to find out what is the number of comparison in this bin. So now what is N? 3.
3. 3.
So half into 3 into 2.
2.
That is 3.
3.
So
Like
like
that,
this,
same 3.
same 3 here, 3 here.
Total 9.
So total is 9.
9.
Earlier total was 36.
4 times it decreased.
Right? So this 36 by 9, you get 4. This is your factor of reduction. Okay. This is the simplest way of understanding binning, that it rapidly decreases the number of reductions. But we are always going to use equal sized bins. That means it's not going to be like one bin has 3 elements, another has 5 elements. Always equal sized bins. See, that same calculation is shown here, that how we get this 9. Right? So for 9 objects without binning, we got 36. For 9 objects with binning, where we use 3 bins of equal size with 3 elements each. Per bin, we have 3 comparisons. 3 bins, we have 9 comparisons. So number of comparison reduces from 36 to 9. That is by a factor of 4 times. So this
As
type
we
of
are
question.
making 1 second, man.
Hmm.
Can I have, as we are making three objects in 3 bins, A, B, C, But the comparison between A and D is missing, no, ma'am. The comparison between A and E is also missing. The
Yeah, ma'am,
comparison
this
No,
is
is
the
no.
question.
happening. The comparison is happening only with those particular bin. But
Yes,
what exactly the comparison between A and D? We don't have the answer.
that's why. Now listen. This binning is not, what did I say in the beginning? That to perform binning, we require an algorithm. That by what idea am I creating these bins? I cannot randomly put objects together into a bin, right? So they must have some common criteria based on which I can bin them into a specific bin. So now to understand this, I was just giving you the definition of what is binning. Now, where do we use this? How do we use this? So, like you said, A and D, there isn't a comparison. Whereas in the original comparison, AD comparison was present. Now, if I have a problem like this, okay, let's say I'm trying to find out how many people have the same birthdays. So, if I have 30 people and I'm trying to find out how many people have the same birthdays. So, instead of comparing every two people's birth dates, is that the smartest way to do it? Or should we introduce binning here? So
We
if
can introduce binning, ma'am.
so, what will be the heuristic? What is the algorithm? What is the idea? How do I bin? How do I know that who to put together in a bin?
We can bin 12, we can make
So
12 bins.
correct. So we can make 12 bins for 12 months. Right now, in each of the bins, like for January, February, in each bin, we only put people who are born in that month. Right. So month wise, we can do a binning. And then inside the bins, of course, if two people are born on the same date, then their birth month should also match. So we will only do comparisons within those bins. That's what I said. That here, like we are using three bins, right, with three elements each. So these elements must have something in common, based on which we did the binning. It's not randomly done, right? So the if you see the birthday paradox problem, so there we use this concept that instead of comparing every two people's date of birth, we are going to use 12 bins, one bin for each month. And all the people born in that month are going to be in that bin. Like all the people born in December are going to be in the December bin. So you compare only among those people. So this will reduce the number of comparisons by a lot if we did not use binning. What will be the factor, you tell me, if I have 30 people or for
Yeah, 30
calculation
into
sake?
30
If I
minus
have
1 by
36
2.
people, let's say if I have 36 people, then without binning, it will be half into 36 into 35,
35.
whatever this is. Right. And if I do binning, where I have 12 bins with three people each, let's say.
Then
So in that
36.
case,
36.
so half into 3 into 2 into this will happen 12 times. Right. So it is giving 36. So of course we can tell that this is a very smaller number compared to this. So this is the implementation of binning why we use. Clear?
Yes, ma'am.
How does 3
The,
into 2 comes in this equation?
Like I said, if I divide into 12 bins of three people each, so inside one bin, how many comparison will be there? N is 3. So half into n minus 1, half into 3 into 2. This is
All right.
inside each bin.
So, ma'am, what is the key difference between binning and iteration?
Not binning and iteration. It is the purpose of binning is to reduce the number of comparisons. If you don't use binning, then you have to do a massive number of comparison like this. If you use binning, that reduces by a huge factor. Right. But
So,
not in
if
every scenario you
someone
can
asks
implement
me
binning.
what is binning, I say it is the reducing the number of comparison. That what is.
Binning is used to reduce the number of comparisons. So binning is basically aggregating the elements with similar criteria together into a bin and comparing within themselves. Right. Instead of doing comparison between every element and every other element, we are using some algorithm or heuristic to bin elements into particular bins where they share some similar criteria or some similar property. So we can just compare among those elements. So the main idea of binning is to reduce number of comparison, but binning cannot be applied everywhere, right? For every comparison, we cannot do binning. only if there is a way to bin them into particular bins according to some common criteria. Clear?
So the accuracy
Ma'am,
part
what
is
is the
not.
common criteria in this? Like in birthday paradox, there is month is common.
Hmm,
So we do the 12 bins.
right.
January, February is this type. But what is the common criteria in this? Because this is the alphabets.
No,
We,
there is no
and
common
if
criteria
we
here. This is just an example to show you how to do binning.
oh,
There is no
okay, ma'am.
criteria here. Okay. When you
So,
add it
ma'am,
to real life problems, then you have criteria.
we can use bin to the common example where the common things appear.
Where you can group certain elements according to some property. Right.
Okay,
Some
okay, ma'am.
property
I
has to
got.
be there. That's why binning is not for every situation. It is only where you have certain properties that match within elements.
Okay, thank you, ma'am.
The accuracy is desired accuracy, ma'am, in the binning when compared to the common comparison.
Accuracy in the sense?
Accuracy in the sense we don't miss any of the comparisons. No, what the outcome of the accuracy? I'm asking
No.
about.
You don't miss any of the comparison in the sense, like here. Of course, in this example, you are missing certain comparisons, right? Like AD comparison is missing, CF comparison is missing in this
Mhm.
one. But in real life scenario, you do not want those comparisons because those are useless comparison. Like in the birthday paradox, you don't want to compare people from January and
Yeah,
February bins, right?
that's true. That's true.
So that accuracy will always be 100%. If you do the binning properly according to the correct heuristic, it will give you 100% accuracy for your problem.
Got it. Got it, ma'am. Thank you.
So from binning, the type of questions that can come is we might ask you that if binning is used in a certain scenario, then by what factor we can reduce the number of comparisons. That type of question might come. Nothing too intense, nothing more than this. Okay. Now, this particular slide, just pay a bit of attention because this is some formula that we have to derive, right? But no need to again memorize any of this. You can derive it yourself. So if I have n items, number of comparisons without binning is what? Half into n into n minus 1. Now, if we use k bins, k number of bins of equal size, then number of items in each bin is how much?
N by K.
N by k. N items, k bins of equal size. So each bin contains n by k elements. So number of comparisons per bin becomes what? Half
Half
into
into n by k into
n by k into n
n.
by k minus 1.
Right.
Same, this formula, just replace n with n by k, right? This is number of comparisons per bin. So total number of comparisons for k bins is what? Half into n by k into n by k minus 1 into
K.
k. This. Now, if you just do some cancellations here and there, like this k is cancelled with this k, then you will end up with half into n by k minus 1. Okay. So factor of reduction, how to find out factor of reduction directly. So this is the formula for that. So factor of reduction, how did we do? In the previous example, we saw that without binning, number of comparisons was 36. With binning, it was 9. So 36 by 9 gave us 4, which is the factor of reduction. That means first, on the numerator, it will be what? Number of comparisons without binning. So that is this, half into n minus 1. Denominator is what? Number of comparisons with binning. That is this, half into n by k minus 1. So if you solve this fraction, then you will get something like this, n minus 1 by n by k minus 1. So this is your factor of reduction.
If we don't use this exact formula and just use that n
You don't
into
have
n
to.
minus 1 by
Yeah,
2,
you can do that.
yeah.
Okay. If it is
Oh,
difficult to
okay.
remember, don't do it.
Okay.
So n minus 1 by n by k minus 1. This, if you apply this formula directly, you can find out the factor of reduction without finding these separately, right? Okay. So that's binning. The summary is what? That number of comparisons between all pairs of items grows quadratically. That means it will grow very fast when n grows, right? Number of comparisons will grow quadratically. We saw the curve. So formula for number of comparisons for n items is half into n into n minus 1. We saw the derivation. Sometimes it is possible to find a heuristic. That is, some common property that allows us to put the items into bins and compare only items within the bins. Only sometimes this is applicable. If there are n items put into k bins of equal size, the number of comparisons reduces to half into n by k minus 1. And factor of reduction is this. Now, these two formula, no need to remember. You can derive it or you can just find it out using whatever is given in the problem. Right? But the concept is clear for everyone, right?
Yes, ma'am.
Yes, ma'am.
So a little bit more theory is left, that is regarding nested iterations and all. So we'll cover that, then we'll do some practice problems. This is visible to you?
Yes, ma'am. It is
Yes,
visible.
ma'am.
See, this is just, I think, week 1 to 4 revision. So we'll just skip to the last part of it. So was this discussed with you, nested iterations? Nested if statements, nested iterations. Is this part
No,
discussed in the
no.
previous weeks?
Better you
right.
touch once, ma'am.
Okay.
Can you discuss it now?
Yeah. Procedures and parameters are discussed, right? What is a procedure? What is a parameter? These
Yes,
things.
ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Then we'll start through here, accumulation through iteration. So the most common use of what is an iterator, first of all? What is an iteration?
Repetition of steps.
Repetition of steps,
Iteration.
right?
Yeah.
So why do we do these iterations? To create an aggregate value, right? To find some sort of accumulation. Like if I want to find sum of maths marks of all students, then what type of iteration do I do? I will iterate through all the cards and then sum up every card's maths marks, right? So I'm doing some kind of an aggregation. So usually iteration is done to perform some kind of aggregation or accumulation. Simple examples of this are like count, sum, average, like I did. Like if we want to count number of um, people who have scored more than 70 in maths. So for that also you have to do iterations, go through every card and increment count. Similarly, we have sum and average. Now we could also simply apply filtering while doing accumulation, like sum of boys' marks. Right? We can find sum of maths marks and then we can put a filter to filter out only sum of boys' maths marks. Right? All of these things we have seen. So doing two iterations one after the another. So use the first iteration to do some accumulation. The variables in which these accumulations are done can be called accumulators. So let's see an example. So second iteration can do filtering using accumulator variables. That means, for example, take this, find above average students. So average is an accumulator from the first iteration. So above average means what? If I want to find above average students in maths, that means first I have to calculate what is the average marks in maths. Correct? For that, I will need one iteration. I mean, a lot of iterations, but one iterator variable I will need, and I'll have to go through all of the cards and do summation of marks and then divide it by count of students, and I'll find the average. Then again, I have to run another iteration where I will again go through each of the cards and compare that average with every student's marks, and whoever has greater marks than average is an above average student. So these are two separate iterations I'm having to perform. Now, this establishes a relationship between any element and the aggregate of all elements. For example, if you want to find out a more frequently occurring words or higher spending customers. So frequently occurring words. So first you have to find out what is the most frequently occurring word. You have to find out the frequencies of every word, right? Then you have to find out which are the more frequently occurring words. That means these things cannot be done in one single iteration or just by one pass over the cards, right? You have to do multiple passes. The easiest example is to find this above average student. So if I have 30 students, I'll do 30 iterations, right? 30 iterations to find out what is the average. That means for each iteration, I will add their marks M1, M2. Like this, I will add their marks, and at the end of the 30th iteration, I'll have the sum of their marks, and then I can divide it by 30, and that's my average. Now I have to run again 30 iterations throughout all those 30 cards and compare every card's mass, that is M1 greater than average. If so, then count is increased by 1. So like this, I can find out above average student, but in different iterations, not in the same iteration. So these iterations which I did right now, they can also be nested within each other, right? So if we want to go beyond the relationship between an element and the aggregate, so when does this occur? When is a nested iteration occurring? Let's see, this one here. So find out if two students have the same birthday and month. So in this case, why do we need nesting? Look, first I will go through, first iteration, I will go through, let's say, for each x in table 1. So table 1 is your scores data set, right? So for each x, now I'll do a nested iteration. Again, pick one more card for each y in table 1. Then I will compare x DOB, that is date of birth of x, is equal to date of birth of y or not. So these are what nested iterations. You can see within one for each block, I have another for each block. Right.
I didn't understand for this X in table 1 and Y in table 1. I don't understand that.
You have seen pseudocode till now, right? So this is how we write for each blocks. If we want to iterate through the table or through the stack of cards. If I want to use scores data set, then table 1 is what? The deck of cards, right? That's how we have used it till now. So
Yes,
for
ma'am, but
each,
I didn't understand.
so for each x in table 1 means what? I'm picking a card from table 1.
For each card. For
Yeah.
each card.
Now I picked the top card from table 1. Okay. Now go into the nested for each. For each y in table 1. Then pick the next card. So now I have two cards. Now I can do a comparison between their date of births. So this is the code to find out if two
So
students have the
basically, we
same
need two
birthday.
decks of cards.
No, it is the same deck. It's table 1 only. One table has 30 cards. I pick out one card from it. That is this X. How many cards are remaining? 29. Pick
29.
out one more card from it.
Ma'am, but here in this case, it will compare the same card with that again, right? I mean, the
Yes.
total
See,
number of
I'm
comparisons
telling
will
you.
be n square.
I'm telling you. See, first you picked this first card, right? Let's say card with sequence number 1. This is your X. Now this particular card you will compare with every other card. That is every one of these 29 cards. So for each X, you are going to compare with every possible Y.
Okay, got it, ma'am. Got it.
Understood. This is nested iteration. So how many comparisons will be there?
N square?
N squared. So if I have 30 cards, compare every card with every other card.
900. 900.
Yeah, like that. Okay. Actually not that. 30 card with, we are comparing every card with every other card, right? So one card is being compared with 29 cards. So every card, that means 30 into 29.
But
This
ma'am,
is the number.
according to the pseudocode, it will compare the
870,
same
ma'am.
card again.
Look,
Because
So
it is,
870, ma'am.
yeah,
870.
why are you saying it is going to be 30 into 30? You explain that.
ma'am, for each x, suppose it will take the first card, and then for each y in table 1, it will also take that first card again.
No. Is it possible? Am I changing the table anywhere? It is the same table on which I'm working.
Yeah, it is the same
When I
table,
take
but
out, see, when I take out X, 29 cards are remaining. Out of these 29 cards, I'm running this inner iterations. So when I take the first card out, first card is being compared with 29 other cards. So first card is now compared with everything. Now we throw away this card in a separate file. Now my file contains how many? So this is the first iteration. Now my file contains 29 cards. Now you pick the second card. Right?
Ma'am, if our
Then
first
how
card is
many?
not, if our first card is not in our desired date of birth, then again the cards will become 30, madam.
No, it is not desired date of birth. What are we trying to find out? That if two students have the same date of birth or not.
Yeah,
not.
yeah. If
Right.
two students have the
So
same
if we
date of
don't
birth,
find,
first,
look, if let's say the first card that I picked here, if the date of birth is 1st Jan, okay, no other student is born on 1st Jan. That means I can do all 29 comparisons, but I will not find a match. But now I am done finding matches for this date of birth. So I will remove this card from the pile. I have already checked this.
Ma'am, this for each means once you take one card, it will be removed, right? I
Yeah,
mean, in the code, it is not mentioned that we are
for the
moving it to
timing.
table 2 or
Yeah, I have not written the entire code. If I show you the entire code, obviously it will be written. Okay, so see, wherever we find a match with Y, X and Y, if we find a match, then you remove that card from the pile. This Y card
okay,
has to also be moved to pile 2.
okay. If it is, if we are removing, then it would be 30 into
Yeah, if we
29.
find a match, then you remove it. Okay. Always, if you
Okay,
find a match, remove it so that we don't do that same comparison again. In one iteration, we are trying to get out all the people with same date of birth so that we can move on to the next date of birth and do the same comparison again. Okay.
okay, ma'am.
Now, doing two iterations, one nested within another. So, nested iterations are costly in terms of number of computations required. So, you can see that there are number of comparisons, right? Lot of comparisons are there. So, it is costlier. So, you will understand this better when you do diploma level courses and you see what is timing complexity, right? Running time complexity. So, there you will see that whenever we have, who is this person?
Ma'am, remove this username there.
One second. Now I think he has left himself. Okay. See. Yeah. So if when you study about that running time complexity, you will see that if I have n number of uh, elements, okay, let's call it elements. So if I have nested for each blocks like this, right? Every n element is compared with all the other n minus 1 elements. Then the complexity for such loops or nested loops that we call it is going to be order of n squared, right? Which is not a good complexity. So we always try to avoid nested loops. But in some cases, you cannot avoid them, like comparison cases, you have to do it. Right. So we could reduce the number of such comparisons by using binning wherever it is possible.
જાતે જવાનો હોય તો પાછા આવી જવામાં શું વાંધો છે?
Okay. Yeah. So now how to store such relationships that we just discussed. All of this will be discussed in the next 4 weeks, right? Weeks 5, 6, 7, 8. When we discuss lists, dictionaries, all of these things, then we will understand this even better, right? But for the first 4 weeks, knowing this much is enough that how nested iterations work. So now we'll move on to your, do you have any doubts so far, whatever we discussed?
No, ma'am, it's clear.
Ma'am, first of all, remove this Asus guy.
Yeah, I am not able to remove him because when I'm trying to remove
He's changing
his
his name. He's changing his name.
no issue. I think this person, right?
ma'am, please
Now he
remove that
changed
guy,
his name
ma'am.
to Lenovo. I can see it. Now Faz. Now his name is Faz.
Yeah, I have removed him. I have reported.
Thank you. I'm sorry.
Let's hope doesn't use any other ID because he last term, the term before that also in foundation level courses, these things happen. In diploma degree, any session, you won't find these things happening because these are first year students, right? So once disciplinary action is taken against them, hope they will learn. Okay. So now let's discuss the practice assignment. We'll just do half of it because not much is left in this week and you still have 2 more sessions to go. We'll just do half of it today. Other half you can do in the next class along with the activity questions. Okay. And also you take your time to go through the rest of the practice assignment on your own before I discuss it. Right? This is visible to you? question?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So for which of the following situation or situations is or are a nested loop needed? So when do we need a nested loop or nested iteration? Okay, this is an MSQ, so look at the options clearly. So to find, first option is to find pair of students who have same birthdays from sports data set. For this, do we need nested iterations? We just
Yes, ma'am.
discussed it.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So we do. To find the pair of students who scored the same marks in physics from scores data set.
Yes,
Yes,
here
ma'am.
also it
Here
required.
Yes,
also.
ma'am. Yes, ma'am.
So this is also required. To find the number of words which have highest letter count. For this, nested iteration is not required, right? So we can
Yes,
perform
yes.
one iteration where we find the highest letter count, and then in a
Yeah.
separate iteration, I can find out how many such words are there
Even
by
in
doing a
one
comparison.
iteration, we can do this, ma'am.
We can get the result, madam. In one iteration itself, we can get the result.
In
Yes,
one
ma'am.
iteration, you can find out what is the highest letter count, right? But
Yes,
can you
ma'am.
find out
That's
how
count.
many such words are there having the highest letter count?
Yeah, for that we have to
Oh, yes,
use
yes.
Do a
Yes, ma'am.
separate iteration, right?
Yes, ma'am.
Yes,
So
ma'am.
two separate iterations, but not nested. These are two separate iterations. So C is wrong. D is to find the number of bills from the same shop from the shopping bills data set.
Yeah, as it
The
is from the
number of
same
bills.
shop, we have to.
So
It's a
this
nested
does
one.
not require nested iteration. Find number of bills from the same shop. What you can do? Just go through each of the cards, right? And maintain three different variables, one for each of the shops. Every time you find a
I have.
particular shop, you add it to that variable, increment that variable.
Yes, ma'am. Got it.
Okay, ma'am. Ma'am, if it says that the same amount from the same shopping bill data set, so then we have to perform nested
Yeah,
iteration.
if you want to compare amount also, then you have to do nesting because now you're comparing amount of two cards, right? So C and D are not the answer, A and B. So option A and B. This is clear for everyone?
Ma'am, what is the difference between nested loop and nested iteration?
Same thing. Nested
Same
iteration,
thing.
nested loop, same thing.
Okay.
Okay. Question 2 is saying the following pseudocode is executed using words dataset. At the end of execution, A captures the number of sentences with at least two nouns that have at most two vowels. Right. So again, words dataset at the end of execution, A captures what number of sentences with at least two nouns. At least means what sign?
At least minimum.
Minimum.
Minimum two.
No, what did I say in last class? Is it greater
Maximum,
than
ma'am.
equal to or
Maximum.
is it less than
Maximum.
equal to?
Equal to or less
Greater than equal to.
It is
Greater
greater
than.
than equal to, right?
Yeah,
And
at
for
most
at
is less
most, it
than.
is less than equal to.
Less than.
So here this is the case. At least two nouns that have at most two vowels. So that is this one. So choose the correct code fragments to complete the pseudocode. So number of sentences with at least two nouns, at most two vowels. So this pseudocode is incomplete. We have these four missing statements, okay, which we have to fill from the options. But first, let's see how the pseudocode is working. So we have A and C, two variables which are initialized to 0. So while table 1 has more rows, read the first row from table 1. That is, now we are going through the cards one by one in the words dataset. In every card you check if part of speech is noun, right? If part of speech is noun and count vowels is a procedure. Okay, so as soon as you reach this part, your control will shift to the definition of count vowels. So for every card, you are going to pass that card through this count vowel procedure as a parameter. What does count vowels do? So it has one variable I initialized to 1, B initialized to 0. Now I will, this while loop will run until I becomes greater than the letter count. So as long as I is less than equal to letter count of this word, while loop will continue. And for every iteration of the while loop, what we are checking if ith letter of word is a vowel. In that case, you increment B, right? And then you do something here and something here. So from this, can we understand that what is B capturing?
Number of vowels in that word.
Could be number of vowels, right? Because we are returning B. So B might be capturing the number of vowels. Now, something is happening here, something is happening here. That we have to find out. Okay, so this number of vowels is being calculated here for every card and then it is returned back to this place. So first you're checking if part of speech of the particular word is noun and whether the number of vowels is less than equal to 2, right?
Yes, ma'am.
That means less than equal to 2 means what? That it has at most 2 vowels. Correct. Then C is incremented. Next, you're checking if the word ends with a full stop. That means if the word is at the end of a sentence. Then you will check if C is greater than equal to 2. When will this happen? C greater than equal to 2. See, you will only
Beginning
enter
of
this
the
nested
sentence
if.
again.
First, tell me when will you enter the nested if? Only if the word you're currently working with is at the end of a sentence, right? Let us take a sentence. I am a student. Okay. First word is I. Check it here. Is it a noun?
No.
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 What
No.
is I?
Pronoun.
Pronoun.
So it is not a noun. So if one part of the if statement is false and there is an and variable, is there any need to check the other part?
No.
And
No.
operator is there, so we won't check.
No.
Okay. So C is not incremented. Fine. C is now 0 currently. Am. So
The verb.
is this a
It's
noun?
not a vowel.
No.
No. No.
It's also not a
No.
noun. So C is again not incremented. A. This is an
It's
No.
article.
No.
also
No.
yes.
So C is still 0. Then student.
It's a
Student
It's a
is,
noun.
noun.
Yes.
it's a noun. So now C and let's find out how many vowels are there. So count the vowels. How many vowels here? U and E.
E2.
So is that less than equal to 2? Yes.
Yes,
Yes.
ma'am, it
Yes.
is.
Yeah. It's
Yes,
equal
ma'am.
to
So
2.
C will be incremented. So C now becomes 1.
1.
Does it end with a full stop? Yes. At the end of a sentence. Is
Yes.
C greater than equal to 2?
How
No.
will but here it is written. Okay, okay. I was reading the sorry.
So C is greater than equal to 2. Is this condition going to be satisfied?
No, ma'am.
No.
Hmm. So only if this condition is satisfied, then we can go further, right? Then we can do this part. Otherwise, just this statement will be executed, statement 2, which is outside of the nested if, right? And then you move X to table 2. So let's say if I do have some sentence for which C value is, let's say 3. In that case, I can enter the nested if, right? 3 is greater than equal to 2. And then you increment A. And something happens here, something happens here. So our job is to find out these 4 statements. So what is the code trying to do? It is trying to capture the number of sentences with at least 2 nouns, at most 2 vowels. So why is that being checked? That there are at least 2 nouns?
That's the requirement of the question.
Yeah, but where am I checking it? In the pseudocode. In which, okay, first tell me in which line am I checking that there are at most 2 vowels?
In the first row.
At most 2 vowels, ma'am. Are you asking?
Yes, at the
We
end of
have to
execution, A
check the
captures number
first
of
row from
sentences.
the
Vowels.
See carefully, number of sentences with at most 2 vowels, not word. So in line 4, we are checking for a particular word, right? If it is at most 2 or not. But I need that in a sentence.
Then if X words end with a full stop, that's why where A we are
So
incrementing
we
A
can
and
see
there
that, so why are we concerned about the C value? Why are we comparing with the C value? So basically C is capturing what? C is capturing,
vowels.
first let's understand what is C. C is capturing the number of nouns in a sentence, right? That have at most 2 vowels.
Uh, 2 words.
Is this correct?
Yes, ma'am.
Number of nouns
With
in a
at least 2 words.
sentence with at most 2 vowels. Okay. So C is doing that. Now we want that the entire sentence should have at most two vowels. So then we are checking that at the end of a sentence, if C is greater than equal to 2. So when will C be greater than equal to 2? If we have found at least two
At
nouns
least two nouns. Yes, ma'am.
with at most two vowels.
Yes,
At
ma'am.
least
Then
two
only,
nouns with at most two vowels. Okay,
yes, ma'am.
look, this thing, I think we have misunderstood it a bit. So the number of sentences with at least two nouns that have at most two vowels means the nouns have at most two vowels, not the entire sentence. Right. It is saying that capture the number of sentences with at least two nouns that have at most two vowels. So here this is worded a little, ambiguously. Can mean two different things. But judging by the question, I think it means that we are trying to capture such sentences which have at least two nouns where the nouns themselves have at most two vowels. Got it?
Yes, ma'am. I got it.
So that we are capturing in C. So at the end of a sentence, we are checking that is C greater than equal to 2. That means are there at least two such nouns with at most two vowels? If that is true, then increment A by 1. Why? Because A is capturing the number of such sentences. Then what should be there in statement 1 and statement 2?
In statement two, we can
Our count is
reinitialize the value
incrementing
of
the
C.
sentences, ma'am. Our count is for incrementing the sentences, if I'm not wrong.
A is counting the number of such sentences. Okay, now tell me one thing. After this is done for one sentence, do I need to reinitialize C to 0 or not?
Yes, ma'am.
Yes,
So
ma'am.
where will that happen? Will that happen in
Statement
statement
2.
1 or statement 2?
Statement 1.
Statement 2, ma'am.
Okay, in statement 2, if I put C reinitialize to 0, then why statement 1 here? What is going to come here in place of statement
Statement
1?
1 is for A.
A. What to do with A? A has been incremented here. Do I need to reinitialize A?
No, ma'am.
No.
Ma'am, initialization happen in statement when I think.
Okay, so if I move C equals to 0 in statement 1, then what happens in statement 2? Fine, let's leave it for now. We know that any one of these statements, this has to happen. In the other one, I don't know what yet, but let's see. In statement 3 and 4, can you tell me what should happen? So here I'm trying to just count the number of vowels, nothing else, right?
Yes, ma'am.
And
Ma'am,
that is
I
being number of
value
vowels is here. So
I
I
value
value
has
has to
to get
increase.
into yes on
Correct.
statement 4.
So here you are saying it should be I is equal to I plus 1.
Yes,
In
ma'am.
statement 3, what is missing? Any idea? So to
No, ma'am.
count vowels, what do I have to do? I have to check every letter, right? So I is going to run as long as the letter count is reached. So every time I pick a letter, we check if it is a vowel. If so, then we increment B, right? Then something happens here. So what is that? So we have idea that two of these things. In statement 1 or 2, one of these should be C equals to 0. In statement 3 or 4, one of these should be I is equal to I plus 1. Now let's check the options. First option is saying statement 1 is not necessary and statement 2 should be C equals to 0. That means reinitialization happens here and statement 2. Statement 1 is not necessary. Could be a possibility, right?
Yes, ma'am.
Yes,
This is a valid
Yes, ma'am.
possibility. And it is saying statement 3 is not necessary. Statement 4 is I is equal to I plus 1. Again, looks okay. Could be a possibility because there is nothing to be done here.
Yes, ma'am.
Okay. Now see option B. Before we reach a decision, let's see all the options. It is saying statement 1 is not necessary. Statement 2 is C equals to 0, which is fine. Then it is saying statement 3 is I is equal to I plus 1. That is increment I here only. Is this correct? Should I
No,
increment I
No,
ma'am.
here?
ma'am. No,
Why?
ma'am.
Because I needs to increment regardless of whether the current letter is a vowel or not, right? So it should be outside of this if block. This if block
Yes, ma'am.
executes only if the current I is a vowel. But we need to increment I regardless. So I is equal to I plus 1 has to be in statement 4. So option B is wrong. Option C is saying Statement 1 is not necessary. Statement 2 is C is equal to C plus 1. But we are not going to increment C. Every time we reach the end of a sentence, we need to reinitialize C to 0. Right?
Yes,
This
ma'am.
is wrong.
Yes, ma'am.
Option D. Statement 1 is C is equal to 0. Statement 2 is not necessary. So statement 1 means here. We are saying reinitialize C here. But if I reinitialize C here, what about a sentence where there it does not have at least two nouns with vowels at most two. In such sentences, then also I need to reinitialize C, right? C reinitialization has to occur whether this if condition is true or not for a sentence. Because every time we go for the next sentence, C has to be reinitialized to C equals to 0. But if I place it in case of statement 1, then it will only occur when in the current sentence C is greater than equal to 2. Right? So C
Yes, ma'am.
equals to 0 should always happen in statement 2 so that this reinitialization occurs regardless of anything. So which option looks correct? Option A?
Option A.
So option A is the answer. This is clear for everyone? Any doubt?
No, ma'am.
Yes, ma'am.
Look, always for such questions, always see what do I need to do mandatorily and what is optional. Here I can see that C has to be initialized mandatorily, right? Regardless of anything. That means it should not fall under a condition. It should happen as soon as I reach the end of a sentence. That means as soon as this if statement is correct. That's why equals to 0 falls in statement 2, not in the nested if, because it does not depend on this if statement. It only depends on the outer if. Similarly, here also, I increment has to happen, whether the current letter is a vowel or not. So I increment will happen in statement 4, not under this if statement. Okay, so this type of questions are a little bit difficult. It will come easier to you when you practice, right? Okay, see this is a very easy question. This pseudocode is executed using library dataset. At the end of execution, n captures the name of a book which has the maximum number of pages. Okay, n is a variable which captures the name of a book which has the maximum number of pages and is written in a language other than English. And a captures the number of pages in the book. Okay. So what are our conditions to find n? Name of a book. It should have maximum number of pages. It should not be written in English. Right. And whatever that maximum number of pages is captured where? In A.
A. Yes, ma'am.
So A is going to be a numeric type of variable, integer type of variable, right?
Yes,
And
ma'am.
n is going to be storing a name. So it is a string.
Language.
It is a string type variable.
Yes, ma'am.
N is storing name of a book. Okay. So A is initialized to 0, N is initialized to none. So we have to go through all of the cards in library dataset. So while table 1 has more rows, as long as you have cards, you pick one card and check if the language is not English and x dot pages is greater than A. So what does this part we all understand that we are trying to check if the language is other than English. What is this part doing? X dot pages greater than A.
This uh,
Highest
Is
number
this
of
is
greater
pages.
showing
than
the pages
Maximum.
is greater
maximum
than
number.
Fine.
A and
This is to
yeah,
find maximum number of pages.
the
Correct.
Yes,
number.
ma'am.
Maximum number of pages. So every time, so this is the comparison that we do to find maximum anything, like we saw maximum marks in maths, like this. So once these two conditions are correct, then A is changed to whatever that current number of pages is, which is greater than the last A. A is updated, N is updated to the name of the current book. So if both the conditions are satisfied, then you do this update. If the rows of the table are shuffled in any random order, then choose the correct options. That means now the rows of your table or this library dataset are shuffled in any random order. Okay. So they are asking that there will be no change in n irrespective of the order of rows. N is the name of the book.
True.
Now, how to identify this? So how can I say that there will be no change in n? How can you say this? Have I mentioned anywhere that there cannot be two books with maximum number of pages written in other than English? There can be,
Yes, ma'am.
right?
Yeah,
So the
yes.
order matters. The order matters for n, not for a. The maximum number of pages will not change, but the name of the book might change, right? If in first order there was a book titled ABC, which had 1,000 pages, and then followed by that, some rows later, there was another book titled XYZ, which also had 1,000 pages. So which title would be captured? ABC
ABC,
or
ma'am.
XYZ?
ABC.
ABC. Because next when I come to this card, I will compare is 1,000 greater than 1,000. That is wrong. So no update will happen. But now if I change the order and XYZ comes first with 1,000 pages and then ABC comes with 1,000 pages, then N is capturing which name?
XYZ.
ABC? XYZ. But number of pages is it changing? It was 1,000 here also, it was 1,000 here also. So there will be no change in N irrespective of order of rows. Is this a correct statement? N is
It's
capturing
incorrect.
name.
No,
It's
no.
incorrect.
No,
This
ma'am.
is incorrect. There might be a change in N based in order of rows. Yes.
Yes.
There will be no change in A irrespective of order of rows. A is capturing number of
Yes.
pages.
Correct, ma'am.
Yes,
This is
Yes,
correct.
ma'am.
Maximum will remain maximum regardless of what is the order. Right. Number of pages will not change. There might be a change in A based in order of rows. No. So B and C are correct options. Is this clear for everyone?
Yes,
Ma'am,
ma'am.
Yes, ma'am.
please
yes,
explain
ma'am.
again, ma'am.
Yes, ma'am.
Which part? Who didn't understand?
Option C.
Option C is saying there will be no change in A irrespective of order of rows. What is A capturing? Maximum number of pages.
Yes, ma'am.
Maximum number of pages. That does not have anything to do with the order of rows, right? Once you find the maximum number of pages, it will never change. The title might be different. Like I said, there might be two books having the same maximum number of pages, 1,000. So the order of their appearance will only change the title of the book that is captured. The number of pages is still constant, right? Maximum is maximum. There is no change in that. In whichever order it appears, 1,000 will remain 1,000 only. Right? Only the name of the book that is captured is changing. Why it is that way? Because if ABC appears first, right, then N is capturing ABC, A is capturing 1,000. Next comparison, when you check that is XYZ written in any language other than English? If yes, good. Then you check is X dot pages greater than A? That is, if it's 1,000 greater than 1,000? No. So once you have captured the maximum number of pages, nothing with the same number of pages will ever be able to update N, right? So that's why number of pages is constant, but the name might change based on the order. Okay, let's do this last one. And then the rest of them you can complete in next class. So question 4 is saying the given pseudocode is executed using shopping bills dataset. Okay, this is a very famous question. Okay, this has come many times in the end term also. So shopping bills dataset, FRAC is a variable which stores ratio of the number of customers who purchased both bread and milk to the number of customers who purchased milk. That means frac is a fraction, right? What is the numerator? Number of people who purchased both bread and milk. What is denominator? Number of customers who purchased milk. Now tell me, is the denominator a subset? I'm sorry, is the numerator a subset of the denominator?
No, ma'am.
Yes,
No,
ma'am.
ma'am.
Why not?
Yes, ma'am. It is a subset.
If I have a big set,
It's a subset, ma'am.
understand, if I have a big set of people who have bought milk, isn't it a subset people who have bought milk and bread?
It's a
Yes.
subset.
Yeah.
Ma'am, denominator is the subset of numerator.
Okay. So there might be a person who has, let's say, if you're saying this is the bigger set. So if there is a person who has purchased milk and no bread, but milk and chocolate, can they be a part of this set?
Not at all.
No.
No.
But the other thing is possible, right? If I have people who have bought milk, that also consists of people who have bought milk and bread. So
True.
denominator is the bigger set.
Yes,
So
ma'am.
what are they asking? Choose the correct code fragment to complete the pseudocode. Assume that there is at least one customer who has purchased milk. That is, it is not an empty set. Okay. So we are trying to count this. We're trying to get this frac, right? So M count and B count are two variables which are initialized to 0. Now, while pile 1 has more cards, you read the top card in pile 1, then some missing code is here. So we have to find out what is that missing code. And then it is saying frac is what? B count by M count. We already saw what should frac be. That means B count should capture what? People who have bought
Bread
both
plus
milk
milk.
and bread.
Milk and bread both.
M count should capture what? People who have bought milk. I don't know if they have bought bread or not.
Only milk.
Not only milk, people who have bought milk. I don't know if they have bought bread or not. That is not my concern. They may have, they may not have. It is the bigger set.
Okay, ma'am.
Okay. When I say only milk, then it reduces the possibility that this person has also purchased bread. But I can't say that because it's not in the question. Okay. So there is a procedure called is item which takes Y and A. Okay. So from this code, I can see that Y is a card, right? And A is what? I don't know what is A. A is some item. Could be. Why? Because I can see that there is a comparison of an item with A. So in this procedure, what is happening? Initially, C is a variable which is set to false. It is a Boolean variable. So while card Y has more items. So in every card, what is there? A list of items that have been purchased, right? In that shopping bill. So we'll go through all of the items one by one. So read an item Z from item list of card Y and check if that item is exactly equal to A. I don't know what A is. A is some item. Okay. So if I find a match, then C is set to true. And remove Z from item list of Y. Why remove Z? So that we don't run into the same item again. So something is happening here. We know what we have to find out is this. That frac is storing this. So now let's look at the options. This type of question, always go to the options to check. Okay. First option is saying in the missing code, that is here. So every time you pick a card from shopping bills dataset, first thing you check is item X comma milk. That means if milk is an item in card X. Okay. If so, then M count is incremented by 1. And if is item X bread, that means if bread is an item in card X, then B count is incremented by 1. So what is this doing? What did we see? B count should have what? People who purchase both bread and milk. Here is B count giving that.
No,
No, ma'am.
ma'am.
It is just
It
giving us
is
people who have
individual.
purchased bread. Yeah.
Red.
Okay. So this is a wrong option. If I follow this and then form frac like this, then I won't get the desired fraction. Let's see second option. If is item X comma bread, that means if bread belongs to the item list of card X, then B count is incremented. If there is a nested if, that means now we are talking about the same card where we found bread. That means this person has definitely purchased bread. Now I'm checking if he has also purchased milk. Then M count is incremented. So now M count is capturing people who have purchased both milk and bread. And B count is capturing people who have purchased bread. Is that the desired one?
No, ma'am.
No, ma'am.
B count should contain people who have purchased both milk and bread. So this is also not the right option. C, if is item X comma milk and is item X comma bread. That means if the person has purchased both bread and milk, then you're incrementing both M count and B count. That's definitely wrong, right? Because now if I do this, then M count by B count will be 1,
Yes, ma'am.
right? So this has to be it, right? This is the only left option. So first we check if milk is an item in my current card. If so, then increment M count. So M count is capturing what? People who have purchased milk. Next, I already know that this person has purchased milk. Next, I'm checking that has he also purchased bread. So it is a nested if. If this if is true, only then this if will execute. Right. So if he has already purchased milk, then only I check if he has purchased bread. If so, then B count is incremented. So B count captures what? People who have purchased both milk and bread. So is this the correct one?
Yes, ma'am.
So option D is your correct
Yes, ma'am.
option. That should replace here. See, you didn't even need to check this part of the code, right? If you understood the problem, this part of the code is not even required. It is just showing you is item. So is item, even if you don't read it, just by looking at the name of the procedure, you can tell what it is doing. It is checking whether a particular item is present in the item list of a card or not, right? So is item is checking like here, is milk an item that is present in card deck? So don't waste time where you can save it. Okay. If you can understand what a particular procedure is doing, don't waste time in decoding all of it because you have 20 questions to solve, right?
Okay. Ma'am, this line number 18 is like, is it necessary?
Yeah. We have to remove it. Okay. Every time we are checking that a particular item is there or not there, regardless of that, so that you don't stumble into that same item again, you have to remove it. Like every time we read a card from a deck of cards, we remove it to a separate file, right? So that we don't read that card again.
Okay.
That same idea is here.
Okay, okay, okay.
So option D is correct. Okay, now rest of the 5, 6 questions are there. You do it in the next class and ask the instructor to start with the activity question after that. Fine. Week 4 doesn't have a lot of content, so it's better you start preparing for quiz 1
Ma'am,
qualifier.
there will be revision lecture for week 3 and 4.
Yeah, sorry.
Ma'am,
Couldn't hear you.
ma'am, which week have more weightage in a
All
qualifier
4, all
exam?
4. But other than week 1, week 2, 3, 4 have a little bit more weightage, but don't ignore week 1. From there also 1 or 2
Ma'am,
questions might come.
ma'am, I'm just asking for which will have higher weightage.
2, 3, 4.
Okay, thank you.
Okay, so you start preparing your quiz for your quiz 1 qualifier exam, and we'll continue with
Ma'am,
this and
there
just
will be
complete the
revision lecture
questions.
for week 1 and 4.
Yeah, yeah, there will be revision session. Okay, 2 revision sessions I
Ma'am,
think will be
ma'am,
there before quiz 1. Hmm.
ma'am, when we
Yes,
will
yes.
get our admit card?
That I don't know. You ask the ops team, okay, or the support team. You ask, they will tell you.
Ma'am, can you go back
Quiz
to
one
the
is both
first question?
objective and subjective, ma'am. Both objective and subjective.
No, all our exams are objective. Okay, question pattern is exactly like this. What you solve in practice graded. Okay, so you will either get MCQ or MSQ or NAD type question. Yeah, which question?
Ma'am, in the first question, the options, here you said that for option number C, we should do it in two types of iterations, right?
Two different
One,
loops. Yeah.
but ma'am, can't we do it in one iteration?
You tell me how to do.
Uh, like, so there will be a variable which is capturing the highest letter count,
Okay.
and like if suppose that variable is A, then if like if x dot letter count is greater than A, then uh, we
Then
should
we reassign A to X dot letter count, right?
yes, ma'am. And
Update A.
right after that, and also in that case, we can like we can do count is equal to count plus 1.
Okay, now see, here is the mistake. Is your A
Uh,
constant? Do you know what is the highest letter count? Or do you have an idea that the next card that I pick won't be a higher letter count? You don't know that. So as long as you don't know what is the highest letter count, you cannot find out how many such words that they are having the highest letter count. So first loop you have to spend trying to find that highest letter count. Like you said, every time I find X dot letter count is greater than A, I will assign it to A. That's how to find the maximum letter count. Now you have to have a
okay.
separate iteration or a separate loop to see how many such words have that letter count that you calculated. Understand? Two
Okay,
things cannot
okay.
happen at once.
Okay, ma'am.
Actually, as soon as we find the letter count, the highest letter, automatically that it is getting incremented, no ma'am? A is
Yes.
equal to A plus
Every
1,
time
it
you
is
find a
happening.
higher letter count, it is automatically getting incremented. So
It
if
is
you even if you
incrementing.
maintain even if you maintain a count, you have to again reassign count. Okay.
Then where is the
This
point of getting again for the highest letter count? In the
no,
first
there is
iteration itself, we are incrementing A is equal to A plus 1.
Ma'am,
no, you're not
ma'am,
doing that.
we can set
In
a
the
condition. If extra letter count is greater than A, then in that if block, we can do count is equal to 0, then count is equal to count plus 1. And then we can do if extra letter count is equal to A, then we can do count is equal to count plus 1. Uh, Can this be possible?
I
Suppose we hit, I mean,
wait, I did not follow you. Come again.
if
Say it again.
extra letter count is greater than A, so A is capturing the maximum number of letter count,
Okay.
right?
See.
Huh.
Even if I do it your way, okay. Even if I do it your way, that in one iteration I'm doing everything.
Yes,
What is
yes.
the question asking? Is a nested loop needed? So are you still requiring a nested loop? No.
Oh, no, ma'am. I'm not asking about the nested loop. I
Yeah,
just want to
you can
know,
do it,
can we do it in one
but
iteration or not?
it will be difficult because then every time you have to reassign your A variable. That means every time A is getting updated, your previous count has to be discarded. So you have to reassign count to 0
Huh,
and then
ma'am.
again start counting.
Yes,
That
yes.
you can do. It's a bit of a difficult code to write. Not difficult, just a bit complicated. Or you can do it two separate iterations. Whatever you find easier, you can do.
Okay. Ma'am, that's what I wanted to know. Like, can we
Yeah.
do it
It's
in one
possible.
iteration?
You just have
Oh,
to do the reassigning then every time
yes, count
A
will
is
be
updated.
0. Then if
Then you
that is
again start
equal, then yes, ma'am.
incrementing.
Yes, ma'am.
Yes.
Okay.
Okay. Yeah. All right. Thanks, everyone. Thanks for joining. Join the next class also. We'll finish up this practice questions. Okay. Until then, you start practicing these on your own. Okay. Thank you. Have a good night.
Thank you, ma'am. Thank you very much.
क्योंकि क्लास खत्म हो गया।